We will be explaining generics in C# by using a console application. The string comparer class compares two strings and returns true if they are equal. The int comparer class and the bool comparer classes both do basically the same thing, but for integers and bools. We would want a more generic class to eliminate the code repetition. Generics allow you to write a single class, method, or interface that can work with any data type. The object comparer class uses a generic type T in angle brackets, which allows the use of any type. The type will be defined when an object is instantiated by the class. Generics delay the decision of which type to use until the very last moment. The isEqual method can take two arguments of any type. The method will determine if the arguments are equal and return a bool. A string comparer object is created from the object comparer class. We can now define the type, string, that the object will use. We then compare the strings dog and cat to determine if they are equal and write the result in the console window. Similarly, we create an int comparer object and define the type, integer, that it should use. We determine if the integers 10 and 10 are equal and write the result in the console window. These are the results of the comparer objects. Generics can be defined at the method level rather than the class level as shown here. The object is created from the object comparer class, but the type to be used is specified in the method instead. The object comparer interface provides a method signature to compare two arguments to determine if they are equal. The interface uses two generics. The method isEqual takes two parameters of type T. It returns a generic of type T result. The string comparer inherits from the iObject comparer interface. The class provides an implementation for the isEqual method. The method defines a type for the argument string and a type for the return value, also a string. Generic constraints define the requirements that a type must meet to be used as a type argument for a generic class. Constraints are defined using the where keyword. Here, the generic type T must satisfy the iPrintable interface. The type must also have a public parameter-less constructor, allowing you to instantiate it within the generic code. In the base class constraint, the generic type must be derived from the base class. The following generic class has multiple constraints and parameters. The generic type T must be a class and have a parameter-less constructor so that it can be instantiated in the generic code. The generic type U must be a struct with a value type such as a string, integer, bool, etc. Contravariance is a feature that allows you to use a less derived, more generic type than originally specified. You enable contravariance in generic interfaces or delegates by using the in keyword for input parameters. The cat class inherits from the animal class. The animal class is the less derived class. The animal feeder class is derived from the generic interface iFeeder. Here we specify the less derived animal class for the type. We create an animal feeder object from the animal feeder class. We create a cat feeder object. We set the cat feeder object equal to the animal feeder object. Contravariance allows us to use the less derived animal class. Covariance is the ability to use a more specific derived type where a less specific base type is expected. This is the natural direction of inheritance. You enable covariance in generic interfaces or delegates using the out keyword for return types. The email class inherits from the message class. It is the more specific derived type. The email receiver class implements the iReceiver interface. It sets the type to email, the more specific derived class. The email receiver object is created from the email receiver class. The message receiver object is created and set to the email receiver object. Covariance allows a more derived class email to be used when a less derived class message is expected. You can use the ref keyword with generic types. This allows you to pass a generic object by reference, enabling the method to modify the original value directly. The swap method uses a generic type ref_t for two parameters a and b. The method can directly change the data of the variables in their memory locations by using the ref keyword. The method effectively swaps the values of the a and b variables. We implement the static class as shown here. Set the initial values for the variables. Swap the values. Write the new values for the variables in the console window. These are the swapped values of x and y in the console window.